Myself, Dr. Shrinivas. I am working as Associate Professor and Head of Pharmaceutics Department, Sinhgad Institute of Pharmaceutical Sciences, Lonavala.Pune. I welcome you all in this video lecture on resveratrol gold nanoparticles, synthesis, characterization, and in vitro anti-cancer activity in this 5th World Congress on Cancer Therapy, Atlanta, US. Let's begin with the topic. Nanoparticles are defined as the particles with a diameter smaller than 100 nanometer. In the recent years, the rapid advancement takes place in the various technologies for the fabrication of different class of nanoparticles. The small size of nanoparticles implies that they could get close to the biological targets of interest and they exhibit the larger surface area to the volume ratio. There are various applications of nanoparticles. Metal nanoparticles have the applications in various fields of science and technology. To mention a few: catalysis, optoelectronics, diagnostics, biological probes, display devices, biological labeling and imaging, therapeutic agents, and drug delivery. Why green synthesis? We have used the green synthesis approach for the synthesis of gold nanoparticles. Many chemical-based methods are reported to be very toxic for the environment. Chemical-based methods are also not cost-effective. The green synthesis has various advantages over the physical and chemical methods, as they are cost-effective, eco-friendly, non-toxic, and can be suitably scaled up. The various eco-friendly approaches for the synthesis of metal nanoparticles are being adopted. Among them, plant-mediated synthesis is being widely explored. In the present research work, resveratrol, a hydroxylated stilbene found in the grapes, wines, and mulberries, are used as a reducing agent for metal salt. It has a cancer chemopreventive activity. It is obtained as a gift sample from Organic Herb Incorporation, China. This slide gives you a global fact about the cancer as per the survey 2012. In 2012 worldwide, there are 14.1 million new cancer cases, 8.2 million cancer deaths, and 32.6 million people living with the cancer within 5 years of diagnosis. This is the lung cancer statistic. Lung cancer has been the most common cancer in the world for several decades. There are estimated to be 1.8 million new cases in 2012, 12.9% of the total cancer cases, 58% of which occurred in the less developed regions. The highest estimated rates are in North America, Northern Europe, with a relatively high rate in Eastern Asia, and the lowest rates again in the Western and Middle Africa. The objectives of the present research work are to prepare the gold nanoparticles using the resveratrol as a reducing agent, to characterize the gold nanoparticles, and to evaluate the in vitro anti-cancer activity on human lung cancer cell line A549. This slide gives you the schematic representation of method of preparation of gold nanoparticles. 100 ml of 0.5 millimolar auriculated solution was prepared in double distilled water. The solution was boiled for 15 minutes. Slowly 20 ml solution containing 250 mg of resveratrol was added and stirred for 3 hours at 1000 rpm. The color change from faint yellow to ruby red occurs, indicating the formation of gold nanoparticles. A colloidal suspension of gold nanoparticle was obtained, which was lyophilized subsequently to get the dried gold nanoparticles. The entire research work was optimized for the resveratrol concentration 100 to 500 mg, auriculated concentration 0.1, 0.5, 1 millimolar, stirring time for 1 hour, 3 hours, and 5 hours, pH of the reaction mixture 4, 6, and 8, optimized to get the stable nanoparticles with the uniform size and shape. The reaction mixture observations for the optimized batch, the color change indicating the endpoint as a ruby red, the pH of the reaction mixture was 3.9, and the surface plasmon resonance band was obtained as 539 nm. The color change here, the two bottles are shown with auriculated solution before adding the resveratrol, and the ruby red color indicating the formation of gold nanoparticles at the end of 3 hours. This is UV visible spectrophotometric analysis of the gold nanoparticles of resveratrol, which shows the SPR band at 539 nm. What is SPR? Surface plasmon resonance. The metal nanoparticles with a diameter between 1 to 100 nanometer possesses a unique optical absorption that is related to the oscillation of surface electrons. This surface plasmon resonance property is dependent on the size and shape of nanoparticles as well as on the surrounding medium. Since the SPR band is a characteristic of nanoparticle composition and morphology, it is often the first property tested to judge the synthesis. According to the published literature, it was revealed that gold nanoparticles exhibits the SPR at 533 nm. The FTIR spectroscopic studies of AURNPs were carried out, and it is shown that the characteristic peaks in the FTIR spectra showed a biofabrication of gold nanoparticles with resveratrol. The particle size analysis of AURNPs was determined using Nanofox particle size analyzer, which this graph shows a very narrow size distribution and uniform particle size of the AURNPs. The size distribution pattern of particles plays an important role in determining the drug release behavior. The particle size of AURNPs was found in the range from 50 to 100 nanometer. The different statistical diameters were determined. The SMD was found to be 95.31 nm and the VMD was found to be 95.38 nm. Polydispersity index is another parameter used for the characterization of nanoparticles. Polydispersity index gives the particle size distribution in the nanoparticle system. It is calculated using the formula PDI is equal to x90 minus x10 divided by x50, where x90 is the maximum particle size in the system, x10 is the minimum particle size in the system, and x50 is the mean particle size in the system. The PDI less than 0.5 indicates monodispersity of nanosuspensions. The PDI of AURNPs was found to be 0.236, indicating the monodispersion of gold nanoparticles. Zeta potential, a surface charge present on the nanoparticles, plays a very important role for loading the anti-cancer drug. The surface charge or the zeta potential of the AURNPs was determined using the nanoplus particulate system. It was found that the AURNP possesses the zeta potential of minus 22.69 millivolt. The zeta potential of the sample gives the electrical charge present on the particles. This helps to know the rate of aggregation within the present system. The nanoparticles with a zeta potential values greater than plus 25 millivolt or less than minus 25 millivolt typically have greater stability. The zeta potential value of AURNP was found to be minus 22.69 millivolt, indicating the stability of nanoparticles. This is a TEM imaging of the AURNPs. It was observed that the AURNPs are spherical in shape and uniform size distribution was found. Anti-cancer activity evaluation of AURNPs was evaluated using the MTT assay. The cell line used was human lung cancer A549. The calculation of percent of lysis of the cells was done by comparing the OD of sample to that of control and also by microscopic analysis. These are the microscopic images of the anti-cancer cells, positive control and resveratrol nanoparticles treated with resveratrol nanoparticles. The resveratrol nanoparticles exhibited the promising in vitro anti-cancer activity with IC50 value of 10 microgram. The lysis was clearly indicated in the micrograph treated with the cell lines treated with AURNPs, while the control shows the less lysis. This indicates a promising anti-cancer activity of the gold nanoparticles. This is our resveratrol, plain resveratrol gold nanoparticles showing the promising in vitro anti-cancer activity against the human lung cancer cell lines.
Anti-cancer activity of AURNP. In vitro anti-cancer activity of AURNP was evaluated using MTT assay. The cell line used was human lung cancer A549 cell line. The calculation of percent of lysis of the cells was done by comparing the OD of optical density of the sample to that of control and also by microscopic analysis. The microscopic images of positive control and the cells treated with AURNPs, resveratrol gold nanoparticle, is shown in this slide. The AURNP slide microscopic image indicates the lysis of the cells as compared to the control, indicating the promising in vitro anti-cancer activity. The IC50 value of AURNPs against the human lung cancer cell line was found to be 10 microgram, which is a very good and can be used or explored as a new anti-cancer agent against the lung cancer. Anti-cancer activity of EURNPs may be attributed to the fact that stilbenes are reported to be potentially important cancer chemoprotective agents, being able to inhibit the cellular events associated with carcinogenesis, including tumor initiation, tumor promotion, and tumor progression. In vitro test on resveratrol inhibited the free radical formation in leukemia cells, inhibited the mutations in another cell line, stimulated the quinone reductase, the enzyme which is responsible for detoxification of carcinogens. So the resveratrol has the known anti-cancer activity, but the gold nanoparticles of resveratrol is giving a promising anti-cancer activity against the lung cancer. In conclusion, the biological process for the synthesis of gold nanoparticles using resveratrol as a reducing agent has been demonstrated. It is simpler, eco-friendly and economical method. The optimized AURNPs are stable and spherical in shape. The AURNPs demonstrated in vitro anti-cancer activity against the human lung cancer cell line A549. Further, it can be stated that this gold nanoparticles of resveratrol can be used to load anti-cancer drug with positive charge, as the zeta potential of these nanoparticles are negative. Positive anti-cancer drugs can be loaded on this and the activity can be further potentiated, and this can be a promising core for loading the anti-cancer drugs. These are the few references used throughout the presentation during discussion. Thank you for giving me the opportunity to deliver a lecture in this 5th World Congress on Cancer Therapy. Thank you to the organizers and thank you to program manager Isaac Bruce. And if you have any queries, please do contact. Thank you.